Okay, for this problem, we're meant to solve this fourth order differential equation with constant coefficients. We notice that the right-hand side is homogeneous, so I don't have to worry about trying to find a particular solution. So the first step is to set up the characteristic equation, r to the fourth minus 8r cubed plus 24r squared minus 32r plus 16 equals 0. And somehow, some way, find the roots of this characteristic equation. The technique that we use is to first find the possible rational roots. So the possible rational roots are going to be things that go into 16, plus or minus 8, plus or minus 16. So these are the factors of 16, divided by things that go into the leading coefficient, which is only plus or minus 1. So I have a total of 10 possible rational roots. All right, let's start testing. So try out 1. 1, negative 8, 24, negative 32, 16. And let's see what happens. So 1 times 1 is 1. Add, I get negative 7. Multiply, negative 7. Add, 17. Multiply, 17. Add, negative 15. Multiply, negative 15, and it does not work. If it worked, I would have gotten 0 here. All right, so that doesn't work. Try again. 1, negative 8, 24, negative 32, 16. And this time, let's try out 2. 1, 2, negative 6, negative 12, 12, 24. Negative 32 plus 24 makes negative 8. Multiply, negative 16, 0. So that works. So what I've done so far is I've established that r minus 2 is a root. And r cubed minus 6r squared plus 12r minus 8. So I've partially factored. Okay, now I have to keep factoring. Now, to keep factoring, I don't go back to the original thing. I've partially factored this, so anything that I do in the future I can just simply work with this cubic here. Now, I notice that clearly 1 is not going to work. I've wondered if it would have worked, this would have worked. Also, 16 is not going to work because now my constant is now negative 8. So I'm down to actually 7 roots to test. So negative 1 might work, plus or minus 8, plus or minus 4, and plus or minus 2. So I'm going to try again, and let's try 2 again on this cubic. So 1, 2, negative 4, multiplying, I get negative 8, 4. 4 times 2 makes 8. 8 minus 8 makes 0, so that works. So 2 is a double root, so r minus 2 times r minus 2 times r squared minus 4r plus 4. So r minus 2 squared, combining these two, clearly that factors r minus 2 squared. So this turns out to be r minus 2 to the 4th power. So the practical effect is that r equals 2 is a root of order 4 of the characteristic equation. So coming back to the original differential equation, that means that we can write the solution as y of t is equal to c1 e to the 2t plus c2t e to the 2t plus c3t squared e to the 2t plus c sub 4 t to the third e to the 2t. So r equals 2 is a root of order 4, so this brings 4 terms, 4 linearly independent terms in the solution of the differential equation. So that would be the general solution of this differential equation. Next we come to the second part of the problem, which is to find the general solution of this non-homogeneous differential equation. And notice that it says the form of. So the question does not ask me to exactly find it. It just simply wants me to find the form of the general solution. So here I have polynomial times e to the 2t. 2 is a root of polynomial of degree 4 in this. So that tells me that the general solution is going to look like this. it's going to be start off the same as what I had before. And then after I finish writing this, I have to write down my particular solution. Okay, I have a quadratic times e to the 2t. So let's write down quadratic, at squared, plus bt plus c, capital C, times e to the 2t. So this matches the form that I see here. However, 2 is a root of degree 4 of the characteristic equation. So for that, I have to multiply this by t to the 4th. And so that is the form of the general solution. Now, for test purposes, you stop here. That's the form of the general solution. If you actually were to do it and actually figure out all 4 derivatives of this mess and plug into the left-hand side and match the coefficients, it turns out that it's going to be equal to t to the 4th times 1 over 80 t squared times e to the 2t. So if you actually do the work, which I'm not expecting you to do for a problem that's phrased this way, it turns out that b equals 0, c equals 0, and a is equal to 1 over 180. So the practical effect is that it's equal to plus 180 t to the 6th times e to the 2t. So that's the actual answer. However, the way the question is phrased, stopping right here is perfectly acceptable the way this question is phrased.